Hello. Hi, everyone. Just a quick question before we start officially. If you can let us know in the chat that you hear us and see us. Still waiting for the information. Just let us know in the chat because obviously we want everyone to participate as well later on. Okay, for those of you who just joined, hi everyone, and I just had a quick question to let us know in the chat that you hear us, since sometimes the tool is having a slight delay. Okay, perfect. We see that. Okay. I'm Jan, and I'm one of the founders of Applover. According to Financial Times, one of the fastest growing software development agencies in Europe, and our specialization is HealthTech, since our mission is to build meaningful software. Our DNA is working on technologies for the most dynamic and recognizable brands on the domestic market and worldwide. We adhere to industry best practice standards using test-driven design and development processes. Today, on one of our webinars, which is a series, by the way, and you're all invited to see the previous ones on YouTube on our channel, and the future will be. We'll be informing about the future webinars in our newsletter that we also obviously recommend. But today we'll talk about machine learning and its use in the health and med industry, MedTech, HealthTech, and we have Philip with us, our machine learning tech lead, that will tell you more about smart medicine revolution and machine learning in HealthTech in general. So you'll be obviously allowed to ask questions and comment. Feel free to just write them in the chat. I'll read them over later on, just not to interrupt the presentation. Without any further ado, Philippe, the floor is yours.
Thank you. And as Jan said before, my name is Philippe Beguero. I'm lead machine learning engineer at Applover. And today I want to talk to you about the smart medicine revolution or machine learning in HealthTech. And without further ado, if we could see the presentation. Yes, thank you. So our agenda for today would be as follows. We'll start with machine learning and why it and HealthTech are perfect for each other. Then I'll try to describe for you how does machine learning work exactly. I'll give you a quick overview of that. And we'll be ready to go to the possible machine learning applications in HealthTech. And the three areas I'd like to talk especially about are personal health monitoring applications, automated diagnostic tools, and personal assistants. Then we'll discuss why are we not there yet, what is stopping us from implementing all those ideas right away. So I'll list some of the obstacles for widespread machine learning usage, and I'll try to convince you that machine learning is not so scary as it might seem. And I'll try to wrap it up with summarize in conclusion sections. So let's begin. Why machine learning and HealthTech are perfect for each other? Well, machine learning has been pervasive in many disciplines for a few years now. But what's so special about it in HealthTech? Why here, of all places, it seems to be a perfect fit for many problems facing us? And I think we should start by defining our goals when it comes to HealthTech apps to better answer the question. And in my opinion, a perfect HealthTech app would need to provide a highly personalized and accurate health insight and be widely available. And I think that we can agree on that as a general idea. Well, due to its flexible nature and ability to process large datasets, machine learning comes to mind naturally as a solution for problems defined as such. And machine learning models can learn from data, extracting the general knowledge and understanding the underlying process. With that basis, they can be further fitted exactly to the specific use case. And what is more, machine learning offers a unique answer to large databases, usually coming with the territory when solving any medical adjacent problems. And currently, no other solution comes to my mind that can process such amounts of data in even slightly comparable time. So, judging by all that, we can say that creating machine learning solutions that both contain a baseline medical knowledge and take into account user-specific data, providing highly personalized care, is possible, I think, and I hope. But let's take a step back. How does machine learning even do that? Well, to answer that, I'd like to start with the basics and first define what constitutes a good machine learning solution. So I would say that any good machine learning system relies on three interconnected parts, or fundamental pillars, in other words. And the first pillar of any machine learning system is data. Simply put, with no data, there is no machine learning. This is the main source of information for any machine learning model. And the data set limits the quality of our model. If the data is flawed, not fully representative of the problem at hand, the model will be as well. There are many possible sources of the data. Not all are as intuitive as we think, since we can use not only static databases, but also data flowing in real time, as for example, robots learning how to walk too. Or we could create our own synthetic data. But no matter the source, the data is crucial, and almost always the more the better. Secondly, domain knowledge, which allows us to understand the data and what they represent, as well as gives us a basis for evaluation of models and their outputs. When building any machine learning model, it is crucial to also learn ourselves, to get to the roots of the model process and try to at least understand the basics of the field we are currently working in and its challenges. With that, we can more accurately choose our approach to the data and construct a model that is better suited to the task. And most importantly, with no domain knowledge whatsoever, well, how we can assess, even initially, is the model any good? And can we pass it for further testing? And lastly, technical knowledge, the know-how that is needed to implement our ideas through code. It consists of both the knowledge and understanding of available machine learning techniques, as well as the ability to handle and process the data correctly. And I think this part is the most self-explanatory and straightforward ingredient, as it is the part that people tend to think of when considering what is needed to build the final product. And while it is, at the end of the day, the most visible part, it still only gives us tools that without the proper domain knowledge, we would be using blindly, and without data, we couldn't use at all. But keeping all that in mind, how can we use our knowledge to extract information from the data and construct a model? And what exactly is a machine learning model? Well, I'll define a machine learning model as a virtual object that contains in itself some general understanding of the problem that it is trying to solve, extracted from the data in the process of learning. So that object is stored in the system and used to make decisions, perform some tasks, or interface with the user, using various parts of systems to do that. But how do we get there? How do we get a ready model? Well, we start with processing our learning data. This includes throughout the exploration to properly analyze it, to find all the missing data points, find the key characteristics of the data. For example, are there any patterns in the data, any trends? At this stage, we can also try to remedy some of the problems that the data may have. So for example, we may gather some missing data points or try to fill them otherwise. Then, once we understand the data ourselves and it's ready, we can choose a fitting model architecture, be it built from scratch by us or an existing model fit for the task. After that comes setting up the training process. All the mechanisms to pass training data to our raw model. And in this step, we must keep in mind that different models take different formats of data and other such restrictions. And once all that is set up, we can begin the training process. And the goal here is for the model to extract some crucial insight from the data and gain the ability to perform the task that it is designed for. After each training session, we evaluate the model. We test it to see how it performs. If it is not satisfactory, we start the training over with other models, different parameters, etc. And this process may take many, many iterations until we arrive at a ready machine learning model performing up to our expectations. And such a model can then be deployed in our application to perform the given task. And now, after all that is cleared up a bit, we can go back to the topic at hand. So, machine learning in HealthTech. And due to its incredible potential coming simply from the ability to learn from the data, as we just talked, machine learning can do many different things. We've seen wide adoption in the fields of computer vision, be it, for example, object detection, face recognition, video processing, but also forecasting and predictions. So any predicting the sales figures, profit margins, stocks, user engagement, and of course ending with language processing, so ChatGPT, all the chatbots, and detecting affects and emotions in written language. All this has been possible due to the exponential growth in both our storage spaces for the data and what follows our data volume itself, but also the available computing power coming with the advent of powerful hardware and cloud computing both. And those changes allowed us to implement gradually more and more complex machine learning architectures, previously described only as a theoretical possibility. And with those revolutionary changes also came novel approaches to other fields, HealthTech included. And as we said before, it presents a unique opportunity for systems able to both handle vast volumes of data and provide a high level of adaptability. And some of the most promising directions, in my opinion, for utilizing those features and combining machine learning with HealthTech would be personal health monitoring applications, automated diagnostic tools, and personal assistants. And to start, let's talk about personal health monitoring applications. So we've got countless possibilities for data sources here, thanks to many smart devices we carry with us every day. And all of them already record, or at least could record, useful for us data. From relatively simple and widespread examples, such as activity levels or heart rate, but could go as wild as recording our brain activity, even. And worth to mention here is the idea of Internet of Things. So connecting more and more ordinary objects into networks to communicate with each other and possibly with our proposed system, serving as even more data sources. And most of those examples, if not all, can be treated as time series, or even pure signals, especially heart rate or brain activity. which opens up the way for endless types of analysis, pattern identifications, anomaly detections, and so on. And all this can be performed in real time if we value a constant stream of information, or it can be processed in batch for more in-depth and large-scale analysis. And all this, that is just a starting point. Another step would be to use that information to extract it and build smart recommendation systems. Maybe suggest life changes based on our findings. So, for example, we detect low quality of sleep, we might recommend reducing blue lights before going to bed, of course. And what else? We can, for example, detect low activity levels. Then we might recommend the user to go for a jog. We may discover some anomalies in heart rate. Then we'll suggest the user to consult a specialist doctor. Or we could even develop early detections and warning systems. And this one is especially interesting as we can already see many such systems being worked on. And a good example that comes to mind is a paper from 2020 that successfully used heart rate data from smartbands to detect COVID-19 infections before any visible symptoms appeared. So another thing that comes to mind would be a hypothetical system aimed at people with existing heart conditions, warning them of possible worrying changes in their heart rate or maybe even incoming strokes. And such systems would, of course, need to be calibrated as to generate close to non-false negatives, even at the cost of some false positives. So we would favor a detection of something that is not there instead of passing information that everything is okay, even though something might not be. After all, it is better to visit a doctor only to find out that you're healthy than to miss something. And those systems offer a unique opportunity for a constant care that wouldn't be possible without machine learning, and that's the most important part here, for me at least. So moving forward, another even more thrilling possibility is to use machine learning as a basis for new diagnostic tools and assistance for medical staff to use. Well, all the tools automating initial patient screening or assisting in diagnosis process would fall into this category. We could, for example, use them to enter symptoms to get possible causes or highlight patients falling into risk groups based on their available medical records. Or we could build a detector for medical scans that highlights parts of scan photo, possibly containing inflammations, tumors, broken bones, whatever you desire. And such solutions could also work as training aids for new specialists, guiding them through their period of learning, highlighting areas that require special attention. And what is really important, the aim of such tools would be to help and take some of the workload off the medical personnel, as the goal is not to replace them. Their expertise is still needed to make the final call, to assess what our system is saying, is generating. And instead, such tools would focus on aggregating all the available info that might not be easily or quickly on hand. And often, decisions have to be made on time constraint. And there may not be enough time to comb through entire medical records or hours and hours of biosignals recording. And machine learning seems like a perfect solution for that. And in that vein, a smart database assistant presenting a first contact physician with not only raw data of the patient, but also a screening report gathered by the system, maybe some key points extracted from the records, could tremendously help to optimize the overworked and straining medical system. This is only really a natural step forward from digitizing our medical databases and records. Maybe think here of a stressed medical team in charge of entire hospital wing with many patients. How more convenient it would be for them to receive a summary on each patient's state without the need of compiling it themselves. But going back for a second to the medical scans applications, in particular cancer detection, it seems that as of late we see more and more publications successfully using machine learning to do exactly that, to detect even hard to identify by our own eyes tissue changes. And I really recommend to check it out for yourself, as even an initial search shows a lot of promising results, a lot of papers toying with that idea, testing new AI to do that. And here, I'd like to again stress that such systems would need to perform up to a very high standard, which is not impossible, I'd like to mention, even if overseen by a medical specialist. Because even if there is a specialist to double check the readings, it is possible to confuse them with a recommendation that is only partially correct. So we need to take special care here. And the last category of systems I'd like to talk about today is very broad and intertwined with previous ones. And it is personal assistants or chatbots and other forms of communications with the user. I think they offer a powerful solution for tasks such and problems such as low user engagement and improving user experience. And such assistants can guide the user while using the app and answer their questions, provide useful info, or maybe even reports generated from other modules of the system. But they also can simply provide a form of companionship. And I'm thinking here especially about the virtual companion apps using powerful conversational AI that can be used simply to pass the time, but also maybe help with loneliness when a real human contact may be limited. It is a possibility. And such companion AI could also message you and gauge your mood based on responses, and then suggest something to improve the mood. Or maybe pass the information that you're not feeling well to a wider system that is assessing your mental well-being. And the system will then make some decisions and try to remedy that. And going back for a second to the diagnostic tool, an AI could even be used as a simplified first contact physician, performing screening and passing the info to a real physician, taking some heat off of him. And a perfect example of this can be found in a study from April this year, in which the research team pitched ChatGPT against the real physicians. And the task here was to answer health-related questions from online forums. Then a board of healthcare specialists evaluated responses from each of the sites on two scales: quality of response and level of empathy towards the patient. And funnily enough, it turns out that ChatGPT not only provided good responses more consistently, it also scored higher on empathy scale. And when you think about it, it is not so surprising. A bot never tires, never has a bad mood, so it can always perform to the highest standard. In turn, a real physician, given more breathing room, can focus on verifying the chatbot responses or analyzing the data the system gathered from the patient. And of course, to implement such a system, it would require a lot more testing and oversight before it is truly ready for the public. But the possibilities are endless, as I said. So, with all that being said, why are we not there yet? And I think the answer is not so easy. but it can be split in two main problems. First, the trust issues, coming from both distrust of the new and unknown, and a simple fact that most people prefer interacting with people, not machines. Machine learning systems seem obscure and sometimes even dangerous, which lowers that trust further. What is more, a lot of studies show that we hold people and machines to other standards. We expect a higher accuracy from AI, give it a much smaller margin of error. We think that machine should simply not make any mistakes. It should be perfect. And even more, we react differently when presented with the same results or assessments, depending on if we were told they came from a human or that they were machine generated. And the second problem would be our technical readiness. Not enough data or low quality data in some cases prevent us from developing truly smart solutions. And remember, with no data, there is no machine learning. Even though the process is going strong, we are still in the phase of digitizing our systems. And as such, we often face problems when trying to integrate with them. But of course, this does not concern newly built apps, but they face a different problem. A new system means no historical data. And that in turn means we need to use external data sources that may not represent our problem exactly. And we need to keep that in mind to remedy this when developing our machine learning models. And I think that we have to keep those issues in mind if we want to develop a solution that will be both useful and used, since that's what really counts. What use is a system that no one uses, simply put. If we disregard them, no matter how good our underlying machine learning models or other processes will be, the system will probably struggle and we won't benefit from it. But not all is doom and gloom, and machine learning systems are not so scary as they may seem. Although complex, at its core, those systems can be rather simple as an idea. And we should present them as such. Simply put, machine learning is the process of finding ways of providing computers with data and tools to understand them. And you can think of it as teaching a human, and one with perfect memory and focused on performing one specific task. And most importantly, machine learning and AI comes as a handy tool for us, not a competitor. It provides unique ways to handle tasks that would be out of our reach, be it due to their extreme tedious nature or scale. I think we can never hope to parse hundreds of terabytes of data in a reasonable time. A machine can. And it can present us with that data in a digestible form, a handy little report. So I think that what's really important here is to demystify the idea of AI a bit. Once it is understood, familiar, and seen as useful, people will trust it more and we will see a wider adoption. And what is more important, a more eager usage of machine learning powered solutions. So to wrap it all up, machine learning, due to what it offers and how it works, is a perfect addition to many health tech applications. There are limitless possibilities for smart systems acting as health monitoring and diagnostic tools. Some of them already tried and proven. And our main concern here in health tech applications should be providing a solution that people can trust and rely on. And with that, I'd like to thank you all for your attention. And if there are any questions, I'll be glad to answer them. So, any questions? Anyone wants something to be explained or more in-depth explanation of something? All right, we've got a question from Nancy. How can we assure that the systems you've talked about are really safe? What can we do to prevent any mistakes made by the AI? And I think I've glossed over a few ways we can do that. But the most important thing is that the AI is not something uncontrollable, not a wild beast to be tamed, but a real system that we can really equip with some fail safes. And the best example here would be ChatGPT that faced many problems after its deployment, but with each found a new bug, new issue with it, it was once and again patched out. And the simple solution here is to test all those solutions, test all those models extensively, to check every single possible usage of that system, to make sure that it is throughout tested and that we really patched up everything. So testing, and once again, testing.
We had some slight connection problems, but Nancy, thanks for the second question. Nancy also asked in the chat, when can we expect the adoption of some of the things you've described?
Oh, thank you. So I think we already see some of them being developed, especially in the research fields, in the academia. But the few coming years will really be a blitz when it comes to solutions such as this. We'll see many AI-powered assistants. Just the other day, Google released AI-powered notebook that we can write in, that it will try to answer our questions, summarize things. So I think we are just on the very edge of that. We will see this coming in the, I think, 1 year, 2 years top.
I also see the comment from Michael. Yes, you'll be able to visit our YouTube channel, but also all of the webinars, these ones that when we talk about machine learning and health tech, will also be recorded. I mean, they are being recorded and they will be sent in the newsletter. So if you're a subscriber, then you get that. Okay, I see Anna mentioning that you've talked about AI learning from data and bad data. And could you explain what those are and how does it impact AI exactly?
Sure. I think it's connected a bit to the previous question, to the question about safety, since our models can know only as much as we give them. So if we give them float data, they won't generate good responses. We can't expect them to. It is just as with a human. If we teach someone with incorrect examples, they won't be able to perform the task. So, for example, if our learning data is lacking diversity, if we pass data concerning only some ethnicities and not all of them, then we will have a flawed model that won't answer all the questions, that will probably not model everything correctly. So bad data is every data that is not representative of a real world, that is missing something. And I think that would be the key point of that.
Okay. Anna, do you need any further, or maybe you have any further questions? Did that? Okay, and obviously, if anyone have anything else, feel free to shoot in the chat. We'll wait a minute, and obviously, for those of you who weren't here from the beginning, it's the first webinar from the series about machine learning, but not the first in the history of Applover, where we talk about tech and tech excellence and digital advisory in general. But this will be the beginning of the series that will be about machine learning, but in a very concrete domain, which is health tech. And by health tech, we also mean subdomains like med tech, sport tech, etc., etc. So we'll be covering those too. Since I don't see any more questions, thank you everyone for attending, and hope to see you soon. Take care, everyone. Philip,
See ya.
thank you very much as well.
Thank you.